Denny, welcome back. Thank you for coming back. I know that last one was probably brutal. Back for number 43. A block has a mass of 25 kilograms and it is sliding down a plane. Okay, so I've created this little diagram here. We've got this block that weighs 25 kilograms and it's sliding down this plane. And the angle of the plane is 30 degrees. Of course, the plane is frictionless. That's important for us to know. We'll get into friction later. This plane is frictionless, so we don't have to worry about that. So 25 kilogram slides down an incline of 30 degrees. All right, so to ensure the block does not accelerate, how much force needs to be applied to the block? Okay, so let's first make sure we know our definitions. To accelerate is to change direction. To have a velocity is to have a certain speed, but I can be cruise controlling down the highway at 60 miles an hour and not accelerating. If I got on cruise control and I'm constantly going at 60, I'm going at a constant velocity and I'm not accelerating. So the object of this problem is not to say how much force does it take to stop this block. The object is just to say how much do we need to apply to it to make it stop accelerating, to make it stop increasing speed. As we know, as we look at this diagram, gravity is going to pull this thing down, and as it pulls it down, it's going to make it go faster and faster because gravity has a force. For every second, it's going to pull it down 9.8 meters if it were pulling it straight down. We'll get to that. So in this case, the question is, how much force do I have to apply to counterbalance the force of gravity? And yes, this thing will still continue to be flying through the air at a constant speed, but the question is how much force is required to make it no longer accelerate. So just like the last problem, we got ourselves a right triangle here, and we just want to figure out our y component this time. We got an x component and a y component. So to figure out the y component, we're going to use our trigonometry again. This again is the sine, it's the side opposite, y equals the sine of 30 equals y over 25. So to solve this, we're going to multiply both sides by 25. Okay, these will cancel out. So the sine of 30 is a half, it's 0.5. So we'll say 25 times a half equals y, or y is equivalent to 12 and a half. Okay, so the force, actually, let's take that back. This is important. So what is this measured in? This block is measured in 25 kilograms. The last problem, we had a girl with a lawnmower, and they gave us that it was 30 newtons. Okay, and that was the unit of measurement, so we know it was a force. This time it's telling us 25 kilograms, which of course we know is a mass and not a force. So the question is, if I know my y component of these kilograms, so when we figured out this y equals 12 and a half, we're saying that the y component of the weight, the mass, is 12 and a half, so it's 12 and a half kilograms. We now got to convert this to our newtons so that we can express it as a force. And we do so just by doing the old force equals mass times acceleration. Okay, the force is a question mark. The mass is 12.5 because we're only concerned with the y component. We're only concerned with what gravity is pulling down. Times acceleration, which is gravity, at 9.8. And as we solve that, we find out that the force is equivalent to 122 and a half newtons. Okay? And you'll have to look in the book. The question asks, what direction does the force have to be applied? Okay? I imagine that the force has to be applied directly up to counterbalance the force, the accelerating force of the gravity that pulls straight down. I don't think the force is on an angle like this. I could be wrong, so double check your book. But I'm pretty sure that the force we want is up. So again, that's going to offset our gravitational pull. As we look at this object and it's coming down this plane, The only force that's acting on it at all, because there's no friction, the only force acting on it is gravity. And gravity is coming straight down. So all we want to do is counterbalance that. So we need a force straight up equivalent to 122.5 newtons.
That can't be a knockout.
And I believe if we did that, that this thing would continue to move at a constant velocity, because it's been moving for some time now. So if we applied that force, that offset, I would imagine the object would start to move on a horizontal plane at a constant velocity of whatever it was moving at prior to us initiating that force. I probably lost you there. So if it was traveling at 88 meters per second, and then all of a sudden we applied this force of 122.5 newtons up, I think you're going to see that same speed now going on a horizontal plane at a constant velocity until acted upon by another force. Okay. And then I hope that helps. I think that's all we need to go over on that one.